everyone. Today we are going to start with the second lab program, and the second lab program says that implementation of your transmission of ping message or trace route over a network topology consisting of 6 nodes. How many nodes? We have 6 nodes, and find the number of packets dropped due to congestion. So now what is the question means? What is the question meaning? First we will understand. Whenever there will be some nodes and whenever the message will send from one place to another place, and due to like if the packets cannot reach or some network issues are there or something is there, that time the congestion will come. And if the congestion will come, that is also known as your traffic congestion. If the congestion will come, that time you can find out some of the packets will get dropped. Okay, so here we have to find out that and one more thing also, it is a network topology. What is the meaning of your network topology? Here there are some variety of topologies will be there: bus topology, star topology. So whenever we are sending any of the packets by using any of the network topology, due to the congestion, how many packets are getting dropped, that we are going to calculate. And also you can see here, we are going to transmit only the ping message. Okay, I'll tell you the difference between the meaning of your ping message. The ping message is nothing but it measures the round trip time for message sent from the originating host to the destination computer that are echoed back to the source. And also the ping operates by sending ICMP, that is nothing but Internet Control Message Protocol echo request packets to the target host and waiting for an ICMP echo reply. This is the definition of your ping message. It means that whenever we will send any message from one host to another host, that time the total round trip time, how much it is taking, and when it will echo back, it means when it will send the acknowledgement back, that time it has to be measured or operate by your internet control message protocol. As we are sending the ping message, so the message has to be controlled by your ICMP, that is nothing but that is a protocol name. Then the echo request packets will send it back to your host for the reply or for the response. That is known as your ping message. So I have told you that in the first lab program, always we will have the connectivity. So that is nothing but your attach agent. Okay. So always we will give the attach agent. So here I will just show you that how we are going to give the attach agent. So first thing is, we will have, this is nothing but our as we know that this is nothing but this is our ping message. Let me increase the font size so that it will be easy for you people to see. So this is my ping message. Okay, so what I'm going to do, sorry, spelling mistake. What I'm going to do, this is my ping message. So how I'm going to utilize this ping message? Okay, as per the question, how many nodes I have? I have 6 nodes. If I will start from N0, it will go like N0, N1, N2, N3, N4 and N5. So there are 6 nodes. Now I have to decide, or I have to make one diagram where my 6 nodes are going to attach. How many source node you are giving, how many destination nodes you are giving, that everything is your choice. So here you can see, if I'll go to my diagram, here you can see already. So always you have to write the program from your diagram, then it will be easy. So when I will go to my diagram, you can see that here there are 6 nodes. Okay, so here you can see there are 6 nodes. What I have done, I have made my N0 as source and N2 as source. So I have 2 source. What any source node you can take. So this N0 is nothing but it is my source node. And also this N2 is nothing but this is also my source node. Okay, so which one is my destination node? As you can see, 3 and 5 are my destination node. So this is my destination node. Okay, this is my destination node, and N5 is also my destination node. So what is there the next one? As you can see in the diagram, I made N1 as a normal node and N4 is the connectivity of my 0, 1, 2, 3 and 5. Okay. So like this only the diagram I have prepared. According to your choice, you can also make your diagram. So now how I will give the connectivity of all this. Okay. We will see here now the connectivity. So as it is a ping message, so what you are going to give for all the ping message, you have to give the connectivity. How you are going to give the connectivity now? So for what I will do is I have to generate some object for my ping message. So what all are the object? As there are six source nodes are there, I should have the objects for my ping message as six. So what I will do is I will give the connectivity N0 to P1, N1 to P2. These things, everything we are going to write in our program. So if you will understand the connectivity, you no need to buy have the program. So N2 to P3 connection, then N3 to P4 connection. Okay. Then N4 is nothing but, as you can see here, this is a middle one. So this one will work as my base station. So I will write this is my base station. Okay. Then I can write here also this side. It will be easy to remember. I will write. So this is my base station. Okay, so now what I'm going to do next now, N4 we have to leave. So now N5 is what? This is my destination node. So for this also I have to give one more ping message object. So this is nothing but my object. So once I will give all these things connectivity, next what I'm going to do is, as you can see here, so here you can see where to where the connection is. So from N0 to, there is a connection to my, so this is my source node, right? N0 and N2. So this N0 and N2, to whom you want to, which destination you are going to concentrate, that also you have to decide. Let me consider, I will send all the packets from my N0 to N5. This is my source, this is my destination. Let's take. You can also take as per your choice. What I will do, I will send the packets from N0 to N5. So if I am sending the packet from N0 to N5, already I have given the connectivity from node to ping message. So in this case, what I have to do, I have to give the connectivity for this N0 to N5. N0 is my P1. I have to connect it to my N5. N5 in the sense which one? It is P5. So this connectivity I have to attach the agent, okay, for the first one. So for the next one, let me take as my source node is N2 and let me take the destination for this as N3. So what I'm going to do, I want to give the connectivity N2 to, I want to give to N3. So this one I have decided I want to give the connectivity. So if I have decided which one I am going to connect, for the N2 I have, it is P3. I will write here P3 to connectivity N3 in the sense P4. So this is my connectivity. Okay. So now only this much connections I'm going to give, and then I will set my NS and all to send the message. So now I guess you have understood how we are going to give the connectivity. The same thing now I'm going to write in my program. Let's go to the program now. As you can see the program, how we are going to start the program. As I told you, always we will start with the NS. So now NS is nothing but new simulator. So once you will write the NS new simulator, automatically you are going to create your NAM files. What is that first NAM file? This is network animator. So what you are going to write? So lab2.nam NAM files. Which one will be in your writing mode? W. It is in your writing mode. So yeah, automatically this program has been saved in the name of your lab2. That's the reason here here I automatically my name file will create in this name also I have to give as per my program name. Next, what will happen, what all are the contents are there inside your NF, all these contents are going to save inside your NS. Trace all the file and keep it inside your NS. Next, again the tracing file has to open. TF, this is the object of my tracing file. What is my tracing file name? lab2.tr. TR in the sense tracing file, and all these things will be in the form of your W, means writing mode. So now trace all the contents. This dollar sign is there, means it is means the contents of the file. So whatever the contents are there inside your TF, all these things are going to save inside your NS. Now the next one will be, I have to create all the nodes. As I have shown you in the diagram, how many nodes we have to create? There are 6 nodes. So I will start from N0 to N5. Same thing I have written. To create the node, what is the syntax? We have to write set N0 $ns then node. So in this way, we are going to create all the nodes. So once you are going to create all the nodes, next one will be what? These things are your nothing but it is like your decoration of your program. N4 I have made it as a shape box. If you will see the output of the diagram, the N4 will be inside a shape box. You can see here in the diagram, it is inside a inside a shape box because it is a base station. So that's the reason I have written here. So next what I'm going to do, here you can see, you can write, these all are your decoration of the programs. Whatever you want to write, you can write. That is not a problem. Next, I want to give the connectivity. Where to where you want to give the connectivity? As you have seen, N4 is my base station, right? So N4 will be in the middle. So all the nodes, the rest of the nodes has to be connected with my N4. You can see N4 is my base station. Okay, so as N4 is my base station, N0 has to connect to N4, N1 also has to connect to N4. In the diagram also you can see the same thing. In the diagram they have also given the same thing to give the connectivity. So here you can see all the nodes has been connected to N4, even including the N5. So what will happen? We'll just go there to the program and we'll see how it is like given the connectivity. So N0 to N4 with this much of data packets and all, drop the tail. So we have used the duplex link. So if we use the duplex link, then only the message can pass from one node to another node. Similar way, all the connectivity has given N0 to N4, N1 to N4, N2 to N4, N3 to N4, and also N5 to N4. You can write as N4 to N5 also and give some packet values and time delay and drop tail. This is about your, as I have told you, this is the connectivity. Next, what we are going to do, we have to set the ping message. I told you that we have to create this kind of objects. How many nodes are there? That many ping message object we are going to create. Where is this ping? It is everything is inside your agent. This new is a keyword which will allocate the memory locations for this P1 because this P1 is the object. So what I'm going to do, where to where I have to give the attach? N0 to P1. See here, I have written N0 to P1. Same thing I have written here, N0 to P1. So now next one also you can see similar way, set P2 ping message attach agent where to where? N2 to P2. Next one N3 to P4. Next one N5 to P5. Whatever I have written here, once you will write in this way in the ROF, then it will be very easy to write. Then what will happen? Once it will give the connections, the next one, what you are going to do, you have to write the packet size and the interval time period. So for the P1, you have set the packet size as this much. That is also your choice. If you want to change, you can change. And for the P1, the interval time period, like after this much of time, milliseconds of time, the next packet has to move from N0 to P1. So this one has given. So you can see everywhere they have given the same thing. If you are writing, it is fine. If you are not writing also, it is fine. It won't matter that much. Only that giving that packet size and interval. That two lines has been repeated everywhere. Once you have reached till here, like till here, N4 or like N5 to P5, the next thing what you are going to do? the base station, the N4 is your base station, right? So who is your source node? As I told you, the source node is your N0 and N2. So as the packets will go from N0 to N2 to N4, you have to set the queue size. Okay, so N0 to N4, when the packets are moving, how much maximum packets we can say? 5. When the source node N2 to destination, like base station N4, the packets will move, what will be the queue limit? 3. When the packets will go from base station to the destination, what will be the queue size? 2. So this much of queue size you have to set. Once that will be done, what you are going to do next? You are going to give the, you have to write the procedure, because ping message will always take the round trip time. It will take the round trip time. So instant variable node, it is there where it is going to receive the node and node ID. Okay, so here I have given the connectivity P1 to P5. Where I got this P1 to P5? As you can see, I have written here P1 to P5, and also similarly P3 to P4. These things, this procedure you have to do. You have to find out the round trip time from here, and then only you can stop your procedure. Once that one will be done, the next one is you have to write these things. Whatever you are saying, this is very easy actually. So what you are going to write? You are going to write at what time you are going to send the packets, at what time. So here you can see all the packets has been written. So here in the first line, ns at zero point 0.1 milliseconds of time, what you are going to do? You have to send the P1 packet. So once that ping message has to be sent. So then again at zero point 0.2, again P1 message has to send. So all these things you have to repeat for I think 12 times you have to write. Okay, you can see why only P1 and P3 only we will write, because that is your, like, from the source. Okay, so P1 and P3, from the source only it is going to send the message. That's why we have given the connectivity. You can see here the connectivity is P1 to P5 and P3 to P4. P1 is nothing but your N0, that is source node. P5 is nothing, P3 is nothing but your another source node here, N2. Okay, whenever you are going to send any packets, you have to send from the source node. So in this way, in the milliseconds of time period, you are going to send the packets. Once the P1 will get over, then you are going to start with the P3 send. So it is not difficult to remember. Once this one will be done, you are going to write the stop. Then we have to write the awk file, because I told you that awk file we should write to calculate the number of packets has been dropped. So here the D is there because first content has to be the D, like how many in the destination, how many packets has been dropped. Then it is a normal like a C program, begin then end. Inside that just I equals to 0. If this is matching with D, then I plus plus. Here I have used the keyword as variable as drop. Drop equals to 0, drop plus plus, and then you go for your printf statement. So the number of packets has been dropped due to the congestion is this much. Then you are writing the $5. 5, what is that 5? You know that I have shown you the 12 fields. So it will take the fifth field, whatever is there, packet ID or something, that you are going to write and how many packets has been dropped. So once you will write, how we are going to execute it, how we are going to start writing the program. Here are the steps. First, you have to open the terminal, or you can say the VI editor. Once the VI editor will get open, you have to write VI lab2.tcl. You know that inside the program, I have used the nam file and the trace file name as lab2.nam and lab2.tr. So first that I have written according to this, because I have saved this program in this name. When I will open this VI lab.2.tcl, one terminal will open. There you have to write this program. Okay, this whole program you are going to type. Whole program you are going to type, except your awk file. Awk file you are going to type in another program. That name of the program also will be different. So you have to type till here, ns run. Once you will type, you have to press the escape key followed by your shift and colon. You know this is the normal thing how you are using. Then you will come back to your VI editor. Then again you have to write one more file name, vi lab2.awk. whenever you will write this awk file, this one will open. You have to write only this much. So two file you have written. One is your TCL file, one is your awk file. TCL file will give you the animation and tracing things. Awk file will give you the number of packets dropped due to the congestion. Once that will be over, you have to escape, shift and colon, come back to your VI editor. Once you will come back, you have to write the execution part. What is that execution? What is a keyword? You have to write nslab2.tcl. Once you will write this network simulator nslab2.tcl, what will happen? You can see this diagram. Okay, in the output screen. What you are going to do? You have to press this play button. Once you will play the play button, you can see here one more line, right? That is nothing but the packets are moving. Packets will move from N0 to N4, then N2 to this N4, and to the destination part it will move. Once it will, if you want to make it as speed, this is a timer line. You can make it as a speed by giving these timer lines. And also sometimes you will see some packets are getting drop also. Okay, whenever the packets will get dropped, that number of packets will go and save. The details of that packet will go and save inside your tracing file. Then what you are going to do? Once you are getting this, that one means you have already created your animation files. Next, again you have to write in your VI editor, because VI editor also will be open and this output screen also will be open. You can minimize or you can click on that VI editor. There you have to write awk space -f space lab2.awk, because the awk file name was lab2.awk. Here we have given. Then whatever awk file is there, it has to calculate, right? From where it will calculate? Because when we have pressed this play button here, all the files are saved automatically inside my lab2.tr. This lab2.tr already I have noted it in my program, TCL program. So these values will come and save inside your lab2.awk. Then what you are going to do? You can see here, this is one more output you can see. Node 0 received answer from node 5 with round trip time is this much. These all are the files has been dropped. Okay. This is your, this one will be there in your VI. How you are going to see that? Again, you have to write, if you want to see your tracing file things, you have to write VI lab2.tr. Okay. If you will write VI lab2.tr, you can see all the packets, whatever has been dropped here. Then already awk file also you have written. Once awk file you will write, you can see the answer as number of ping packets dropped. See, here the awk file notations are there. Awk -f, this some name of your awk file, then tracing file name. So what will be the answer? The number of ping packets dropped due to the congestion are this much. Okay, so this is your answer. So with this, your lab program 2 gets over.